If derivative of u vector with respect to t is equal to cross product of w with this u, and derivative of v vector with respect to t is a cross product of w vector with this v, then we need to show that the derivative of cross product of u and v is equal to the cross product of w with cross product of u and v. Right, this we need to show first. And secondly, we need to show that if a, b, c are constant vectors, then if r vector given to us, this is the path of the particle moving with constant acceleration. Okay, let's move on to the first solution. We need to show this left hand side to be equal to this right hand side. But before that, please take this as your remark. What is the cross product of two vectors with the third one? How to remember this? Take the dot product of these two. So taking dot product of c vector with a vector and multiplying this with the remaining one. Then minus, take the dot product of c vector with b vector. So now taking the dot product of c vector with b vector and multiplied it with the remaining one. ठीक है, पहले c वेक्टर का डॉट प्रोडक्ट a के साथ लेना है और b के साथ मल्टीप्लाई कर देना है, फिर c वेक्टर का डॉट प्रोडक्ट b के साथ लेना है और a के साथ मल्टीप्लाई करना है. राइट, हैविंग द डिफरेंस ऑफ दीज टू. नाउ लेट्स मूव ऑन टू द सॉल्यूशन. Let's take the left hand side. So taking the derivative of first vector and the cross product with the second vector plus first vector its cross product with the second one. Very fine. Okay, so this is further equal to, what is du by dt given to us? It is a cross product of w with this u vector. It is a cross product of w with this u vector and is having cross product with v vector plus u vector. Okay, cross product of what is dv by dt? It is the cross product of w with v vector. This is given to us, right? Now applying the remark on these three. First take the dot product of v with w vector. So it is v vector dot product with w vector and multiplied with this remaining one u minus, now taking the dot product of v with second vector and multiply this with the remaining one w. Similarly, applying the formula on the second one also. When started with v, we have taken the dot product with the far one vector, right? So when starting with u, take the dot product with the far one first, which is far away, right? So taking the dot product of u with v and multiplied with the remaining one w minus taking the dot product of u with w now and is multiplied with the remaining one. Now we know that u dot v vector is equal to v vector dot u vector. The dot product is always same, right? So I'm having v dot u and here u dot v with the opposite signs. So these two are cancelled with each other, right? So cancelling these two because of this reason. So we have now remaining v dot w into u minus u dot w into v. Again using the remark, here w is having the dot product with v, w is having the dot product with u, which means I need to write w outside and having its cross product with u and v. What vector should I write first? First we always have the dot product with the far away vector. So writing v far away from w and writing u vector first. So hence we have shown this right hand side. Okay, next question. Okay, now the next question. Show that a, b, c are constant vectors, then okay, r vector is this. This is given to us. We need to show that it is moving with the constant acceleration. R vector is given to us, that is A vector t square plus B vector t plus C vector. What is the velocity of the particle? It is the derivative of r vector with respect to time t, right? So let's derivate this r vector with respect to t first. So we are calculating the velocity. So derivating the r vector with respect to t. A, B, C are constant vectors, right? Okay, derivating the first term we get 2a vector t. Derivating the second term with respect to t, we get only b vector. Derivating the third term, that is 0 because c vector is constant vector. C vector is constant vector. So we have the velocity of the particle to be equal to 2at plus b, right? Okay, what is the acceleration of the particle? We need to show that the particle is moving with the constant acceleration. What is the acceleration of the particle? It is the derivative of the velocity with respect to time. Do you remember? So we need to derivate this velocity now with respect to t. So derivating 2at plus b. Okay. Derivating the first term we get 2a vector. Derivating the second one, because b vector is a constant vector, that is 0. B vector is constant. So what we are getting? Twice of a vector, twice of the constant a vector, which means the acceleration is constant. We have shown that the particle is moving with the constant acceleration. Okay, thank you.